Hi friends, welcome to Answers. So today this is 74th episode in space series. So today we're going to discuss about a celestial body which sucks everything inside. These are known as black holes. These things do not reflect any light, but they absorb everything which they come across. So black hole. The normal way of forming a black hole is just when a star goes supernova. So when a star is at the end of their life, they will start to collapse inside themselves. As they become larger, they'll start just pushing to themselves until the pressure explodes, leading to a supernova. And inside the supernova, there could be two things that could happen. One, a normal black hole, and two, just a neutron star. So today we're going to discuss about black holes. So black holes are formed when this supernova happens, but the gravity takes over everything. So the gravity pushes everything in, making it a very, very, very dense place. Very dense. So, and then a black hole is formed at first. So this black hole is just born, just a baby small thing. So it will start to suck everything which came out of its parent star. Yes, like all of the supernova gases. It will go into this, and sometimes it will get clogged and just start going in a circle slowly into the black hole. This is known as the accretion disk, and these black holes have different masses varying from the star which they started from. So for example, this star had 10 solar masses, that means 10 times the mass of our sun. That means this black hole will also have the same mass. Meanwhile, if there's a planet which has the same mass as Earth, like similar mass of Earth, hypothetical planet, and suddenly it became very compressed, it could also become a black hole. Anything, if it is compressed, will turn into black hole with the same mass of the object which was compressed, but in a very, very, very tiny scale. Compared to the star, this new black hole is very micro. The star couldn't even see it if it was still there. Yes, pretty small. So these stars are known as stellar stars. Stars which are born out from stars. Black holes formed out from dead remains of stars. These stellar black holes are just the black holes which came out of dead stars. Just a small summary of stellar black holes. Next are the supermassive black holes, and there's also intermediate ones, but they're just black holes with like thousands of solar masses. So let's just skip to the normal supermassive black holes. So supermassive black holes have millions or even billions of times of solar masses of the sun. Yes, so these are humongous, ranging from larger than the solar system. Yes, so the largest black hole we ever know is a black hole known as TUN 618. Yes, this 11 solar systems can literally fit side by side just for diameter. Yes, it is so big. The circumference is literally 195 billion with a B in kilometers. It is the largest black hole we know, but technically it's not. So let's go back. There's another black hole. So normally the theoretical limit for the black hole mass up to now is just 5 times 10 to the power of 10. This is 50 billion. Yes. So this is how much we up to now we can the theoretical limit for a black hole's mass. But two other black holes, out of which the largest one, Phoenix A, has literally double of that mass. 1 times 10 to the power of 11. It is these two black holes, which are very larger than the theoretical limit, or we are still unsure about their mass. We don't know if they are larger or if they are smaller, and they have lots of billions of solar masses.
What are the units?
I mean, the units here are solar masses. Sorry, the symbol is okay. This is the solar mass symbol. So each of this one thing, this is literally 100 billion solar masses. Yeah, this is very large, very, very large. So Phoenix A is still doubted if it exists or not. Yes. So now let's go to the main parts of a fundamental black hole. Let's take a black hole. Let's name it test subject, which we cut apart to show what is inside because we want to kill things. So first, there's a small thing, a thing which has it is just a point with no length, nor breadth, nor height. It is known as a singularity. This is where everything sucked into the black hole goes. This is the singularity at the middle of the black hole. No one knows where it leads to another alternate universe, or just stuck there forever, or into a white hole where something else will come out, just the opposite of black holes. So next is just like a circumference of the black hole, the boundary between space and the black hole's inner parts. This is the event horizon, where suddenly you'd be sucked inside in a process known as spaghettification, where if you were there, you'd be turned into noodles or spaghetti. Yes, tasty. Yeah. Okay, this is the event horizon. Next is another layer, circumference thing known as the photon sphere. In this sphere, if light is going in a straight line, that means just think that the light is going in a straight line here. If there is no gravity there, it will just go on forever. But at this point, if there is a black hole here, it will start to curve around forever without going in nor out of the black hole. It depends on the gravity and the mass of the black hole. But this photon sphere is literally next to the event horizon. Yes. Meanwhile, for some others, it is too far away from the main black hole part. Yes. So, not last and finally, but one important part is the acceleration disk. Yes. So everything which gets captured will start to go here, where it will spin slowly and slowly until it finally reaches the black hole, and it will take millions of years to do that because it takes a lot of time to rotate in this yeah. Yes. So yeah, this is like a black hole having a slow feast. Next, there's a jet. Very powerful black holes have this jet. Yes. So let's take another view for a black hole. This is the acceleration jet. The acceleration disk. Okay. So now, because it has, so for black holes which are getting a lot of mass inside of them, they'll start to release that mass in the form of jets. Yes. So jets, these could also create new stars, but can also destroy many stars, as they also contain just the same thing which is used to make stars and also delete stars. Yes, the same thing inside stars to be exact. Yes. So these jets can be larger than the galaxy which these black holes are even in. So some of them could even be larger than the Milky Way itself. Not once but twice. Yeah, they are pretty humongous. Very, very large. Yes. So the larger the black hole, the more massive the black hole, the larger jet it has. And these are mostly in supermassive black holes, in which in supermassive black holes there's a subcategory known as quasars. So quasars are just these ones which have jets, but when the scale is crammed up to 11%, Yes, out of 10. So they are very powerful. They can literally destroy anything in their path. So if there's a star here, just in this pot, then this jet will literally destroy everything there. So yeah, this for today about black holes. Bye.